In this video, I want to introduce you to three special sums. The first is the sum of the first n whole numbers. So just whatever n is, add up the first n whole numbers. Well, let's just say that I'm going to call that number q. And let's just say I take that number that is q and I write it down. Just the way I have it up here. And then I write it down again. But instead of going from 1 to n, I add the number up from n down to 1. So I write it kind of in the other order. Now that shouldn't matter, right? Because addition works. It's commutative, it's associative. I can regroup it, but commutativity says I can reorder it, and that's really the most important part. So I need to think about what this sum would look like if I read it from right to left. And I'd have a number n, and then I'd have one less, and then one less than that, all the way until 3, 2, 1. So I have a number n, and then I'd need one less, and then one less than that would be 2 less than the original number, and then, well, I'd have to add that all the way down until I saw that plus 3 plus 2 plus 1. And I don't know, on this sum, maybe now I realize that I should have had an n minus 1 here, and n minus 2 here, that I could have filled in some information at the end of that sum. All right, well, so I have two copies of q. Let's add them together. And what I'll do to add them together is just add each slot. So n and n plus 1, well, those add together to give me n plus 1. 2 plus n minus 1 also gives me n plus 1. N minus 2 plus 3, well, that's going to give me n plus 1. And what I realize is that in all of the positions and all of the columns, I end up with a n plus 1, no matter the two things I was adding together. So I have this long list of things I'm adding together, and here I have n plus 1 plus n plus 1 plus n plus 1. And what I realize is that I know how many n plus 1s I'm adding together, because there's one in each column, and there's 1, 2, 3, 4, 5, 6, 7, 8 n columns. And so this number that's written here has to be the same as n times n plus 1, right? I'm adding n plus 1 together to itself n times. But this number's q, this number's q, which tells me the number I just got was 2 times q. So q is n times n plus 1 all over 2. And so that becomes a special formula for the sum of the first n whole numbers. Let's look at a concrete example where we can use that formula. Let's add up the first 7 whole numbers. One plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. All right, well, let's see. Let's just add these together. So 1, 2 make 3, that makes 6. 4 more is 10, 15, 21. The sum of the first 7 whole numbers is 28. Let's see if our formula works. So it says n times n plus 1 all over 2. Well, 8 divided by 2 is 4. 4 times 7 is 28. Our formula seems to work. Now, we've already proven it, so it kind of had to work, but let's just do it one more time. Let's imagine that we had to add up the first 10 whole numbers. All right, well, I know that the sum of the first 7 whole numbers is 28. So I just need to add, let's see, 17 and 10 is 27. I need to add 27 more to that. And I'm going to get 55. All right, well, according to our formula, that should be 10 times 11 all over 2. 10 divided by 2 is 5, times 11 is 55. Well, now let's add up the first 100 whole numbers. but let's just use the formula. So n times n plus 1 all over 2. Well, 100 divided by 2 is 50, times 101 is 5,050. The sum from 1 to 100 is 5,050. Okay, well that was one of 3 special formulas I want to show you. The other 2 we won't prove. To prove the other 2, we would need to use a tool called mathematical induction. And for this course, we'll just take these as formulas. So this is the one we just saw, the sum of the first n whole numbers. There's also a formula for the first n squares. N times n plus 1 times 2n plus 1 all over 6 gives you the sum of the first the first n squares. Let's look at a simple example to test the formula. So let's just add up the first 3 squares. 1 plus 4 plus 9 is 14. Now let's see if our formula gives us 14 as well. So n, well that's 3, times 4, times 2 times n is 6, plus 1 is 7, all over 6. Let's see, that's 3 times 4 is 12, over 2, over 6 is 2, times 7 is 14, and our formula seems to work. That makes me happy. All right, and then the final special formula we will need is the sum of the first n cubes. This formula looks a lot like the first one, except for it is squared. The sum of the first the first n cubes, n times n plus 1 all over 2 quantity squared. And so let's test that. Let's add up the first 4 perfect cubes. 1 plus 8 plus 27 plus 64 is 100. All right, testing the formula. N is 4 times n plus 1 all over 2 squared. 4 times 5 is 20, over 2 is 10, and 10 squared is 100. All right, well, it's our goal to use these 3 special formulas, the algebraic rules for finite sums, and everything else we know about sigma notation, so that we can finally get back to talking about the sums that give us area under curves or displacement.